Welcome to a fascinating journey into the world of forensic palynology, where microscopic pollen grains become silent witnesses to crimes. In this video, we'll explore how these tiny particles, invisible to the naked eye, have revolutionized criminal investigations, helped track wildlife trafficking, authenticated valuable goods, and even solved decades-old cold cases. From the groundbreaking 2018 Australian murder case to cutting-edge scientific techniques, prepare to discover how nature's most resilient microscopic messengers are changing forensic science forever. Our story begins in 2018, when Australian investigators finally closed a decades-old murder case. The breakthrough didn't come from DNA or witness testimony, but from something far more unexpected: microscopic pollen grains found on the victim's clothing. This case exemplifies the growing field of forensic palynology, where pollen and spores become crucial evidence linking suspects to crime scenes. As Dr. Lynn Milne, one of only a handful of forensic palynologists worldwide, explains, pollen grains are nature's perfect forensic evidence. They're microscopic, nearly indestructible, and geographically specific, essentially creating invisible fingerprints of location. What makes pollen so powerful as evidence is its ubiquity and persistence. Every day, the average person unknowingly collects thousands of pollen grains on their clothing, hair, and possessions. These microscopic particles, typically between 10 and 100 micrometers in diameter, travel through air currents and attach to surfaces through electrostatic forces. During peak flowering seasons, a single cubic meter of air can contain up to 8,000 pollen grains, creating an invisible environmental signature that follows us everywhere we go. What truly sets pollen apart from other types of forensic evidence is its extraordinary resilience. The walls of pollen grains contain a substance called sporopollenine, which is one of the most chemically resistant natural compounds known to science. This remarkable durability allows pollen to survive in sediments for millions of years, long after DNA and other biological evidence have completely degraded. This resilience was dramatically demonstrated in the 2006 Danube suitcase murder in Vienna. When a body was discovered in a suitcase, investigators used pollen analysis to determine that the victim had actually been killed in the Carpathian Mountains of Slovakia, not in Austria where the body was found. The pollen profile recovered from the victim's clothing contained a distinctive mixture of mountain pine, Pinus mugo, and spruce species unique to that specific mountainous region, directly contradicting the suspect's alibi. Unlike conventional forensic evidence that requires careful preservation techniques, pollen remains viable even after exposure to extreme conditions that would destroy most biological evidence. In a remarkable case from Northern Ireland in 2017, palynologist Dr. Patricia Wiltshire was able to recover and identify 20-year-old pollen samples from archived clothing of a murder victim. This crucial evidence ultimately led to the conviction of the perpetrator 2 decades after the crime had been committed. The geographical specificity of pollen assemblages creates what scientists call a palynological fingerprint, a unique combination of species that can pinpoint locations with remarkable precision. Some plant species produce such distinctive pollen that a single grain can narrow a location to within a few square kilometers. This specificity has proven invaluable in cases where perpetrators attempt to obscure a victim's true location or create false alibis. The power of this geographical fingerprinting lies in the fact that different regions have distinct plant communities. When pollen from multiple species is found together, it creates a unique signature that can be matched to specific locations. This is particularly valuable in cases where investigators need to establish a timeline of events or determine if a suspect's alibi holds true. The combination of different pollen types, their relative abundances, and seasonal variations creates an environmental record that's extremely difficult to fabricate or manipulate. For investigators, this means that pollen evidence can reveal not just where a crime occurred, but sometimes even narrow down the specific time of year based on flowering patterns. Modern forensic palynology employs sophisticated techniques that go far beyond simple microscopy. Scanning Electron Microscopy, or SEM, creates detailed three-dimensional images of pollen morphology, allowing species identification with unprecedented precision. Flow cytometry technology can rapidly sort and count thousands of pollen grains per second, while DNA metabarcoding identifies plant species from environmental samples even when pollen is degraded. Isotope analysis determines the geographical origin of pollen by examining carbon, nitrogen, and oxygen ratios. These technical advances have transformed what was once an incredibly painstaking manual process. Traditional pollen analysis required experts to visually identify each grain under a microscope, a process that could take weeks for a single sample. Today's automated systems can process hundreds of samples daily, creating digital libraries of pollen profiles that can be compared across cases and jurisdictions. Recent innovations have pushed the boundaries even further. Confocal laser scanning microscopy now creates three-dimensional reconstructions of pollen grain architecture with nanometer precision. This technology has revealed previously undetectable surface features that can distinguish between closely related plant species. In 2020, researchers at the University of Munster developed an even more advanced technique using Raman spectroscopy. This method identifies the chemical composition of individual pollen grains without destroying them, preserving the evidence for future analysis. New Zealand has emerged as the world leader in forensic palynology application, primarily due to the pioneering work of Dr. Dallas Mildenhall, who has worked on over 200 criminal cases. The country's geographical isolation has created distinctive pollen profiles that vary dramatically across short distances, making it ideal for forensic applications. In a groundbreaking 2019 study, researchers at the University of Otago demonstrated that individual plants of the same species can have distinct pollen signatures based on trace element composition. This could potentially allow investigators to match pollen not just to a species but to a specific plant. New Zealand's justice system has formally recognized pollen evidence since the landmark 1992 case of David Tammihir, where pollen analysis contradicted the defendant's account of events, leading to his conviction for double murder. The country's isolated evolution has produced numerous endemic plant species found nowhere else on Earth, creating highly localized pollen signatures. Some native New Zealand plants, such as particular species of Nothofagus, commonly known as southern beech, produce pollen with such distinctive morphology that a single grain can be definitively linked to specific forest regions. Taking this expertise further, the New Zealand Police now maintains a national pollen reference collection with over 20,000 samples mapped to precise GPS coordinates. This comprehensive database allows investigators to match crime scene pollen to specific locations with unmatched precision. The country's investment in forensic palynology has paid dividends beyond criminal justice. The same techniques are now employed to verify the provenance of high-value agricultural exports like Manuka honey, protecting a $350 million industry from counterfeiting. The applications of forensic palynology extend far beyond murder investigations. Wildlife trafficking investigations have been revolutionized by pollen analysis, which has helped identify the origin of illegally harvested timber and poached rhino horns by matching pollen embedded in the material to specific forest regions. This has provided crucial evidence in prosecuting international smuggling operations. In the food industry, authentication researchers have developed pollen fingerprinting techniques to verify the geographical origin of premium products like honey, olive oil, and wine, detecting fraudulent products that claim false regional designations. This protects both consumers and legitimate producers of high-value regional specialties. Historical mysteries have also benefited from palynology. When analyzing the Turin Shroud in 2020, palynologists contributed evidence suggesting it originated in the Middle East, not medieval Europe as some had claimed, adding a new dimension to this historical debate. The field has found unexpected applications in counterterrorism efforts as well. Following the 2001 anthrax letter attacks in the United States, forensic palynologists identified rare pollen grains mixed with the spores, helping investigators narrow the production location to a specific geographical region. Similarly, pollen analysis of soil adhering to vehicles and equipment has helped military intelligence track the movement of insurgent groups in conflict zones. Environmental litigation has emerged as another growth area for forensic palynology. In a precedent-setting 2016 case, pollen evidence was used to establish the timing and source of industrial pollution in a watershed, resulting in a multi-million-dollar settlement. The pollen record preserved in sediment layers provided a historical timeline of environmental changes that conventional water testing could not detect. Despite its enormous potential, forensic palynology faces significant obstacles. The discipline requires rare expertise. Fewer than 40 forensic palynologists practice worldwide. This shortage of qualified experts creates bottlenecks in investigations and limits the adoption of these techniques in many jurisdictions. Analysis is also time-consuming, with a single case potentially requiring identification of thousands of individual pollen grains. As Dr. Von Bryant of Texas A&M University, one of America's few forensic palynologists, notes, the biggest challenge is awareness. Many investigators don't collect pollen evidence because they don't understand its value or how to preserve it properly. This lack of awareness means valuable evidence is often overlooked or improperly collected at crime scenes. The field also confronts skepticism within some legal systems. Unlike DNA evidence, which provides statistical probabilities, pollen evidence often relies on expert interpretation of assemblages rather than exact matching. This has occasionally led to challenges in court regarding its admissibility, particularly in jurisdictions unfamiliar with the science. Defense attorneys may question the subjective nature of pollen identification or the statistical significance of matches. The lack of standardized protocols across international boundaries further complicates its acceptance in global investigations, as different countries may have varying standards for evidence collection, analysis, and interpretation. Emerging technologies promise to make pollen analysis more accessible and efficient in the coming years. Automated pollen identification systems using machine learning algorithms can now identify common pollen types with 80 to 95% accuracy, dramatically reducing the time required for analysis. Portable DNA sequencers like the Oxford Nanopore MinION allow for rapid field identification of plant material, potentially bringing laboratory capabilities directly to crime scenes. In 2021, researchers at Massey University in New Zealand demonstrated that pollen protein profiles could be used for rapid identification, potentially reducing analysis time from weeks to hours. We are just beginning to understand the full potential of what pollen can tell us, says Dr. Patricia Wiltshire, a leading UK forensic ecologist. Each grain carries a remarkable amount of information about location, season, and environment that can speak for victims when nothing else can. This sentiment captures the profound impact this developing field continues to have on forensic science. As climate change alters plant distributions and flowering times, forensic palynologists are creating contemporary pollen reference collections to ensure future investigations maintain accuracy in a changing world. These efforts recognize that historical pollen records may become less reliable as plant communities shift in response to changing climate conditions. International collaborations like the Global Pollen Project are digitizing collections and standardizing identification protocols to create accessible resources for investigators worldwide. These initiatives aim to overcome the limitations of expertise and establish consistent standards that will make pollen evidence more widely accepted in courts globally. These microscopic messengers, invisible to the naked eye but ubiquitous in our environment, continue revealing secrets that would otherwise remain buried, proving that sometimes the smallest evidence speaks loudest. The extraordinary durability of pollen means it persists when other evidence has long since vanished. A single grain, perfectly preserved for decades, can connect a suspect to a crime scene or reveal the true origin of trafficked goods. The field of forensic palynology represents a perfect intersection of botany, geology, ecology, and criminal investigation. It reminds us that nature itself records human activities in ways we're only beginning to fully understand. As technology advances and awareness grows, these microscopic witnesses will likely play an increasingly important role in our justice systems worldwide. From solving cold cases to protecting endangered species, authenticating valuable goods, and preserving historical truth, pollen analysis offers a unique window into both past events and current mysteries. The next time you notice pollen dusting your car or making you sneeze, remember that these tiny particles are not just seasonal irritants, they're nature's record keepers, silently documenting our movements through the world and occasionally helping to solve its most perplexing mysteries. From solving decades-old cold cases to tracking wildlife trafficking and authenticating premium products, forensic palynology has emerged as a powerful tool in our investigative arsenal. These microscopic grains, resilient enough to survive millions of years yet specific enough to place someone at an exact location, represent nature's perfect witnesses. Despite challenges like limited expertise and standardization issues, the field continues to advance through machine learning, portable DNA sequencers, and international collaboration. As climate change reshapes our botanical landscape, forensic palynologists are working to preserve this invaluable record-keeping system. The next time pollen triggers your allergies, remember that these invisible particles are not just irritants, they're silent chroniclers of human movement, capable of speaking for victims when all other evidence has vanished. In the intricate architecture of a single pollen grain lies the potential to unlock mysteries, bring justice, and reveal truths that might otherwise remain forever hidden. Thanks for watching. Please like, subscribe, and hit the bell icon for updates. Your feedback is appreciated. We hope to see you again.